So in this video, we are going to discuss about clippers. So the circuit with which the waveform is shaped by removing the portion of the input signal without distorting the remaining part of the waveform. It is called as clipper. Okay, so it will clipping means it will remove some portion of the input signal without distorting the remaining part of the signal. Okay, so it is also called as voltage or current emitter or selector or slicer. So the application of this circuit is it is used in digital computers, and radio and television receiver, then it is used in radars. The main component used in the clipper is diode, which we know it is used for rectification, and resistor. Okay, so you know the purpose of resistor, right? During the it acts as the current limiting devices. Okay, then we require a power supply, right? Input, right? So we can classify this clipper as four categories. So one is based on positive clipper, and another one is negative clipper, and another one is biased clipper, and the last one is a combination of positive and negative clipper. Okay. So first let us discuss about positive clipper. So I told you the circuit which is having one diode followed by a resistor, and this is your output. We know V of E0 T, and this is your input signal VI of T. Okay, and consider VI of T. This is your VI of T. Okay, it's a sine wave, right? So which varies from minus Vm to Vm. Okay, and this is your time period, right? So what happens when the input voltage is positive? So when the input voltage is positive, the diode is open circuited, right? When VI of T is positive, during the positive half cycle, during the positive half cycle, diode is open circuited. This diode is off because this is positive compared to this one. So this becomes reverse bias. So this is open circuited. If this is open circuited, and the circuit looks like this, right? and this is your Vi of t. So the input will not reach the output, right? The input will not reach the output. So V0 of t is equal to 0. Right? So during the positive half cycle, so during the positive half cycle, there is 0 till this one. Okay. So what happens to a negative half cycle? So during the negative half cycle, Va of t is equal to as during the negative half cycle. This is for forward bias. So the entire thing, what is Va of t, will reach the output, right? That is V0 of t. Okay. So whatever the value here will come exactly like this. So you can see the positive half cycle is flipped and the negative half cycle is remaining same. So I can redraw the circuit like this is also a positive paper. Okay. So either you can draw it like whatever that I draw in the previous diagram. So this is also a positive paper. Okay. So the next one is negative paper. Okay. So you have to draw the circuit. You have to change the direction of the diode. Okay. So this circuit is similar to that of this one. Okay. So this is also a so this one is similar to that of both are same, but you can see this is nothing but I have changed the I have interchanged the diode with the resistance and the resistance with the diode. Okay. So this is called a series negative clipper, and this one is shunt negative clipper based on the position of the diode. Okay. So if you see, this is your input. Okay. And Va of t. Okay. So during the positive half cycle, since both the circuits are same, whatever the diode is short circuited, so diode is on. Therefore, the Vi will reach the V out, right? Va will reach the V out. So exactly, and during the negative half cycle, diode is off. Therefore, the output will not reach. Say the input will not reach the output. So you will get this kind of waveform, right? So this is called as a negative clipper. Okay. So this type of circuit we have already discussed in the half wave rectifier, right? Next, biased clipper. So So this is one in circuit diagram. So you can see this one is same as that of positive clipper, right? So extra you have a biasing bias, which is this bias will help to remove the small portion of positive or negative or cycle of the small voltage. So hence this is called as biased clipper. So this bias is named because the adjustments of the clipping level is achieved by adding a bias voltage which is in series with the diode or resistors, right? So this one is similar to that of this one. Okay.
It's in your table instead each one.
So both the circuits are same. So suppose this is your VA of t. Okay. And since the VR is positive, let me assume this is 2 volt and my VR is 1 volt. Okay. This VR is equal to 1 volt. So we know that this is nothing but a positive clipper. Okay, so the negative off cycle will come as it is, right? A negative off cycle will come as it is. Okay, so instead of clipping the whole portion, during the positive off cycle, what happens during the positive off cycle? The diode is off, right? So it is open. Therefore, my V naught of V of 0 of t is equal to VR. Okay. So during the positive cycle, my output is VR. Okay. So you can see my this portion, right? And this portion is get clipped out, right? It is clipped out. Okay. So this is nothing but a positive clipper, right? So now let me explain about. So the next one is a biased negative clipper. So so here it is a series biased negative clipper, and this one is similar to that of resistor followed by a diode and bias. Okay, both the circuits are same. So what happens when so this is how the input signal is, okay, and let me assume this is 2 and this is -2, and this is 1 volt. Okay, VR is nothing but 1, that is -1. Okay, -1 volt. And you know that this is nothing but a negative clipper. Okay, so during the positive cycle you will get the same output. Okay, why? Because and during the negative off cycle, that is during the negative off cycle, diode is off, therefore V naught is equal to minus VR, that is nothing but -1 volt, right? So So this portion is get clipped out. Okay. So during the positive cycle, so whatever the voltage, that is 2 volt is here, that is present at the output of the V0. Okay. So what is a V0 value? V0 is nothing but 2 volt. So next one is a combination clipper. So the circuit diagram is, so I'm going to club this one. So let me name this one as D2 and this one as D1. So I'm going to club this to diagram. Okay. So this is nothing but D1. This is nothing but D2. So what will happen? So if the input is like this, okay, since I have combined these two values, I will get the output. Okay, suppose this is VR and this is also VR, and this is 1 and this is -1. Okay, so we'll get the output like this, right? Since it is a combination of the first two values. Consider for the given circuit. So far we have discussed about the ideal diode, so which will work when it is even when we are giving a forward bias. So we know the cut-in voltage of this diode, right? So the cut-in voltage of diode is 0.7, right? So 6 sine 2 pi ft. Okay. So this is your input signal, which is ranging from 6 to -6 volt. Okay. And this is your frequency. Okay. So what about the output? So I can write it as this is 0.7, so I can write this one as 5.7, right? So whenever during the positive cycle, it goes maximum up to 5.7, right? It goes maximum up to 5.7, and during the negative of cycle, it is open circuited, so whatever the input will reach the output. Okay. So basically how I will remember means you have to draw this 5 volt. If I consider the diode is ideal and it will conduct when it is 0, right? So it is 5. So since the diode is facing downwards, it should be like this. Okay. Whatever the signal below this one will appear in the output. Okay. So consider another circuit. Also looks same as and the VR value is 10, and what is VI means? VI is nothing but 20. Okay. This is 20 and this one is minus 20. Okay. And they have given the value of RF, this forward resistance of the diode is 100 ohm. Okay. So you can tell this is 10.7, so it should be less than 10.7, but here I have given the value of forward resistance RF is equal to 100 ohm, and RR. Okay. So RR, that is reverse bias is infinity, that is VR is equal to 0. Okay. So how to determine the value? So V naught is equal to Vi minus VR, that is 10 volt, into RF divided by RF plus R. Okay. So what is the value of R? R is given as 1200, right? Plus VR. Okay. So what is VI? VI is nothing but 20 minus VR is 10. RF they have given us 100 ohm divided by 1200 plus 100 plus 10. So if I solve, I will get 10.78. Okay. So simply this is 0.7, you will get 10.7. So this is your VI, and the V naught must be 0 V. Is something but 10.78. Okay.